So this last set, next set we're going to be doing by solving quadratics by square roots. And so some of them are going to be straightforward, like this question here, where you just take the square root of both sides because we already have the square root by itself. And so we have x is equal to plus or minus the square root of 10, or square root of 100, which is 10. So my answer is x is equal to the solution set plus or minus 10. Some of them you'll have to do a little bit of extra work, where we need to get the square root by itself first. So we add 6 to both sides. And so we have 9x squared is equal to 16. Then we divide both sides by 9. And so x squared is equal to 16 ninths. Now that we have the square root by itself, we take the square root of both sides. And so x is equal to plus or minus, well, the square root of 16 is equal to 4, square root of 9 is equal to 3, and so 4/3. And so my answer is x is equal to the set plus or minus 4/3. Now let's look at number 42. As we get further into these, you're seeing that they're getting a little bit more, this one actually, we had to get the 121 moved to the right-hand side. So we add 121 to both sides, and we have x squared is equal to 121. Now we take the square root of both sides, as we have the square root by itself. And so we have x is equal to plus or minus 11. So x is equal to the solution set of positive and negative 11. It's your final answer. Number 43, we have to do it again. We're going to add the 64 to get it to join the 17. And when we do that, we have 4x squared is equal to 81. Divide both sides by 4. And so x squared is equal to 81 fourths. So the square root of 81 and the square root of 4 are the two things we need to take the square root of. So we want to take the square root of both sides. That's where we knew we needed to get those. And so x is equal to plus or minus 9/2. And so x is equal to the solution set of plus or minus 9/2. Let's look at number 44. This time we have something inside that squared, but that's all we have on this side. So we go ahead and take that first step of taking the square root of both sides. And that gives me x minus 7 is equal to, well, 60 isn't something I can take the square root of, not give a perfect square. So I have to go back to my chart, and I have to think of the numbers on that list that would divide into 60. And 4 is on that list, so 4 times 15 works. And so the square root of 4 is 2, so plus or minus 2 square roots of 15. Now I need to take and move that 7 to go ahead and join the other side. So add 7 to both sides. X is equal to plus or minus, 7 plus or minus 2 square roots of 15. And so when I write it in set form, x is equal to the solution set of 7 plus or minus 2 square roots of 15. And the last one of these is a little bit more complicated just because a lot of us don't like to work with fractions, but it works the same thing as we've been doing. So we've got to get this 1/4 moved over here with the 27. So to do that, we're going to multiply by 4 over 1. And so we have x plus 2, that quantity squared, is equal to 108. So I take 108 and I try to think of what numbers are a factor of 108. And you always look for the largest one. So something that you can try if you have troubles trying to find it is you take 108, if you divide it by 2, and then start testing from that point down, that can help you find them. But 36 and 3 would multiply to give you that 108. And 36 is 6 when you take the square root of it. So you have plus or minus 6 on the square root of 3 is equal to x plus 2. Now we move the 2 over to join the right-hand side by subtracting 2 from both sides. And we have x is equal to negative 2 plus or minus 6 square roots of 3. Now we write it in our set form. X equals the solution set of negative 2 plus or minus 6 square roots of 3.